So here again we are looking at two different kinds of logarithm rules, and they are related in this case, however. So we start with the first row again, where we're looking at the first example A, and probably notice that it looks very similar to what we just had looked at, but we're looking from a slightly different angle. So we're doing the same steps, however, again. So we have 5 to the power of what number gives us 5 to the first power? Well, that's even easier than the other example where we had to think of the 1 ourselves. In this case, it's already written there, right? So essentially, so we're already given the exponent. So when we find the logarithm, the exponent is already written there, so we just write down that exponent. Now the very crucial important part is here that the bases are the same. So the base in both cases is 5, and therefore that works. So let's look at our next example. So same scenario, 2 to the what power equals 2 to the 5th power. Well, again, it's already written right there, so we don't have to think too hard that this is 5. And then the next two examples, just to refresh our memory again, to also what does it mean when we just have log? That means we have a base 10. So we are asking ourselves 10 to the what power is 10 to the 3rd power? Well, clearly that is 3. And the same way for the last one, we are asking ourselves, so we have ln again. Ln means base e, so e to the what power equals e squared, or that is 2, and therefore our answer is 2. So we can also almost talk about like cancelling, so one cancels the other, which makes sense because they're inverses of each other, they're opposites of each other. The one is the undoing of the other. So when the bases, as long as the base is the same, so the base for the logarithm and the base for the exponent, the exponent is our answer. Now in the second row, we are doing the exact same part, just vice versa. So we can just kind of, from what we just did before, guess that the answer to the first one is 1, because the exponent and the logarithm kind of are the undoing of each other, cancel each other. However, how can we explain that a little more? Well, if we think about what is logarithm to the base 5 of 1, we get to practice our first rule that we discovered today already, so that would be 0. So then what is 5 to the 0 power? That equals 1, right? So if we are able to find the logarithm with a nice number like we are in this case and all the other examples, we can almost all the other examples, we can actually see that this works. It just cancels out. So in the next example, we can do the same thing, but let me rewrite it a little differently. We can just write it straight and say 2. Now what is logarithm to the base 2 of 8? Well, we are asking ourselves 2 to the what power gives us 8, and we know that that is 3. 2 to the 3rd power is 8. And now we have 2 to the 3rd power, and which is 8. So our answer is 8. So the 2 to the power and the logarithm to the base 2, they have the same base, and therefore cancel each other out. And therefore in the next example, again, same thing. So we have 10 squared, because logarithm to the base 10 of 100 is 2, and then our answer is 100. Now in the last one, we cannot find just an easy logarithm, so here we are going to explain directly that the answer here is 3 based on what we found from the other examples, at the very end we can again see our general formulas, that when we have the first row, logarithm to the base a, so any base, and then that same base, a to the x power, our answer is x. And the same way, that was now what we did for the second row, is a to the logarithm to the base a of x also equals x. It doesn't matter whether we are first taking the logarithm and then our exponent, finding our exponential expression, or if we are first finding our exponential expression and then the logarithm of that. If it's the same base, they cancel each other out and equal x.